Welcome, everyone. I think today someone from Ericsson was going to talk about query resource management, right?
Yep.
Exciting.
Yeah, it's gonna be my colleague from Ericsson, Evaristo. I think you haven't met him before, and he's the one with the orange T-shirt over there. So I will hand him over. Start.
Okay, thank you, Alberto. Hello, everybody. Okay, nice to meet you all. If it's okay for you, I plan to show some slides with a real use case, and maybe we can discuss how we approach it, and maybe, some gaps that maybe we can discuss, or maybe it's different approaches to solve the problem, or different ways to tackle this if interesting. Okay, so I will share my screen. Let me know if you can see it properly. I hope you can.
It works.
Okay, yep. Good. So first, okay, let me introduce myself. As Alberto commented, my name is Evaristo. I work with him in Ericsson. We are using Geode as a repository for subscription management in mobile networks. Okay. As you know, we are contributing to the community, and so far so good. The normal ups and downs with the technology, solving problems and so on, and thanks for your help, okay, in all the discussions and so on. Related to this problem, maybe I can start making a description of the problem itself. That probably sounds to you, but basically, I have tried to describe with Strebalits. Basically, what we see is that OQL's query execution can be really resource intensive, even a single one. Usually, queries taking 1 core per server maximum. Okay, maybe not all servers involved, and tons of memory could be needed. Okay, it depends on the query, but in our use case that I will explain later, we see allocation rates close to 1 gigabyte per second. Okay, that is significant. Different kind of problem is that there are some unbalancing on the servers when you execute an OQL query usually in a partition region. Okay, and I think there are good reasons, basically to try to reduce signaling. I assume that's the main reason. But actually, what you can see is one server is taking a portion of the job, especially the one receiving the query. That's the one taking more job. Other servers will be involved, and maybe others are doing nothing. Okay, so there is some kind of unbalancing in the cluster itself. And I would say that the hard part is to protect with OLTP traffic or the transactions traffic or the sort, or let's say the fast and short transactions that, at least in our case, are what we call traffic. Okay, maybe we can discuss if the OQL self-serve are traffic or not, and maybe in some cases they are, maybe in others they are not so relevant in terms of latency or the amount of time that you can wait to get a response from the servers. Okay, and here as very simple techniques you can use in order to protect the traffic. Just as an example, you can try to limit in the application side the number of queries, or run the queries in low traffic hours, and this kind of stuff. Okay, so high level, this is the description of the problem from our point of view. Maybe I can go to our concrete use case with some more numbers. Any question to this? Is it clear, or does it sound to you as a common use case? Okay.
I have one question actually. When you say the query is unbalancing the cluster, is it? Is that? Wouldn't that simply be a matter of where the data lives? I mean, if you have partition regions, then different sets of data live in different places, right? So isn't it dependent on what you query, where it goes, and whether it utilizes all the servers or not?
I don't think that's the case. I mean, if you have partition regions, ideally all the servers should do something, right? That's good. What could be ideal in share the job between all the servers. But if you check how an OQL is running, that's not the case. The server receiving the query assigns all the buckets that is hosting itself, no matter if they are primary or secondary. So they assign that bucket to itself.
I see. I see.
You know, and maybe other servers are doing nothing. So you can see some balancing, let's say, okay, some servers working more than the others and this kind of stuff. But there is a good reason that I think is to reduce signaling, okay? But maybe in some cases, this is not the best.
Okay, I see. Understood.
Okay. Okay, so let me show our concrete use case. That is a real one. So we are, as commented, using Geode as our repo for our subscriptions. More or less some data for you to give an idea. We are running around 10,000 transactions per second in each server. Our heap utilization is around 30%. Okay, so we have quite a lot of room for processing in the heap. Our typical latency for this traffic is around the 5 milliseconds. We are using the G1, and we keep more or less, or not more or less, with this pressure is under control. Typically, our pauses are on the range of 50 milliseconds, more or less. Our per instance, we are using pods with 8 cores and this amount of memory, and more or less our amount of subscriptions that we store there is around 1 million. But I mean, these are our mobile network subscriptions that in the Geode regions are more entries. Okay. We have a feature that is called application counters. So the main goal of the feature is count subscriptions that met certain criteria. Okay, subscriptions that are located, I don't know, now in Boston, subscription with guys that have, I don't know, red hair, whatever. Okay, this kind of queries. Our goal is to run these queries and try to minimize as much as possible the impact on the traffic, okay, that are the real signaling in the mobile network. And I mean, we started with continuous queries. I mean, we found some niches there, and we moved to OQLs. Basically, all of our OQLs are select count, and I mean, the region and the conditions to be met. Okay, basically, this is what we are trying to achieve. Some numbers. For instance, this traffic in our case are generating all this amount of TPSs. The allocation rate on the servers is around 600 megabytes. Okay, that I consider it moderate for the kind of hardware that we have. And the G1, sorry for the mistake typo here, is around 50 milliseconds pauses running in good shape, I would say. Okay, now we run this application counters feature, the single OQL. Okay, it depends how complex the OQL is, and we observe the following. Okay, first thing is how much CPU is consuming. Is 1 core. Okay, it's good. It's predictable. You know it, so you can provision the hardware, and it's okay. We observe some unbalancing in the cluster. Okay, so some servers more loaded. I mean, this is, at least for our case, maybe not so good, because I think the balancing can be better. But probably the main problem is this one. OQLs is a huge allocator. Okay, so we see allocation rates around 1 gigabyte per second, highly dependent on the query, and it's hard to predict. Okay, it depends on the query. The allocation can be less or even more. And what's the problem here is that a single operation is able to, I mean, to send the GC to the generated mode. Okay, because it has a so huge impact in the garbage collection heuristics that garbage collection could start to take different decisions because it cannot cope with this allocation rate and needs to start taking harder measures. Okay, in the case of G1, we observe more mixed collections, and basically the GC pauses are multiplied by 5, 10. I mean, it depends. Okay, not sometimes even if full stop the world, we can see that. Okay, it depends. So we tried several things to try to address the problem, and I mean, I will tell about all of them, even the ones that didn't work. Okay. So we, as commented at the beginning, I mean, we started to limit the number of queries run sequentially. So only one of these application counter at a time. So we run all the queries sequentially. Like we have geographical replication. Okay, that's a core in our systems. So we can run, at least in its geographical replica, one query. So if we have 2 replicas, then we can run 2 queries in parallel. If we have 3 that are the normal use cases, then we can run 3 in parallel. We categorize the queries, and the heavier ones, we run those during the night. Okay, so less traffic during the night, more resources for this, less impact. Okay, we're using indexing for obvious reasons. Okay, the faster the queries are running, the less of impact in our traffic. So I mean that's obvious, and we try to find a good trade-off between the memory usage on the CPU that are saving and the programs that are saving. But I mean, this is obviously working. Like our queries as servlet count, different balancing could help us. What I mean, if all the servers will work, that means that executions will be faster, because now the server that is making the queries lower is just one. So I mean, we can reduce the total amount of time, and if we can spread the load, it's much better. Okay, because in general the system is more predictable. So what we were doing is, okay, move query executions to be invoked from a server function, and I mean use the optimize for write set to true. So what we are basically achieving is that the OQL are run on primary buckets for the partition regions. We are using all our data is duplicated, so I mean the server will just handle the data for the OQL in which is hosting the primary bucket. Okay, so we achieve a good balancing in the server of the job, and total execution is faster. So I think, wanted to say probably is very simple, but it worked for us. We were trying to down prioritize the OQL executions in the server. So at the beginning, we tried to play with threads priority in the server functions. Okay, trying to make not so good things. But this is not working. Basically, only works if the servers are exhausted. Okay, they don't have more CPU. In that case, this kick-ins, but usually that's not the case. Okay, so even if you set lower priority to the thread running the OQL, it makes no effect in normal use case. So more stuff that we tried. Okay, like our G1 was degenerating and the pauses were close to the limit for our use case. We started to experiment with different GC. In this case, we chose Shenandoah GC. We are using OpenGDK 11. So, Shenandoah is ported to GDK 11 with production level quality. CGC is not there yet in GDK 11. So we chose this garbage collector. But at the end, the problem is a bit the same. Basically, you are trying to put more pressure in the GC than the one that it can handle. Okay, so basically, the garbage collector go to the generated mode, and in the case of Shenandoah, with this allocation pace, at least with some OQL queries, basically Shenandoah was saying, okay, I'm running in cycles back to back. Okay, I just finish the garbage collection and I start the next one, and even sometimes I don't have time and I need to stop the application and performance of the world. Okay, so at the end, all the low pauses promise of the garbage collection are gone, and was even worse. We tried, okay, to tune it. So at the end, we put more CPU, more memory. We dedicated more resources to the Shenandoah, but I mean, to a point that it was insane. Okay, it wasn't worthy. So basically, we needed to add, I don't know, 40% more CPU, 50% more memory. I mean, it was the ROI for us was not good. There is an interesting job done there. Probably this could be interesting for the Geode community. That is both Shenandoah and CGC are working on generational implementations. So far, they are not generational. So this means that these garbage collectors are working fine when the allocation rate is low or moderate. Okay, probably only with the traffic, it could work for us, a bit in the limit. Okay, but could work. With the OQLs, I mean, this can explode, to be honest, at least in our case. Okay, but I think this is a very interesting area, especially now that CMS is becoming deprecated. That was like the default GC for Geode. And honestly speaking, I think that Shenandoah or CGC, they are probably the right collectors in the future for Geode use cases, and especially with this kind of evolution. Okay, this is generational implementations. Okay, so I mean, maybe it's worthy a different talk, and in case you are interested, we can share our experiences in Ericsson. But not everything were bad news with Shenandoah, and I mean, we discovered something very interesting. That is that Shenandoah has a feature called pacing, and the idea basically is to try. It's some kind of effort to make the GC fair. Okay, usually garbage collector is quite unfair because a single thread can make almost all the allocations, but when the GVM is paused, all the threads are paused. Okay, but Shenandoah, when going to the generate mode, it has a feature that is pacing. That what it's trying is to stall the threads that are allocating more. That is quite similar to what we would like to have. Okay, we were testing it, it works, but it's hard to tune it. Okay, it's hard to say how much you need to pace. Maybe sometimes you pace what you don't want, or you pace the counters even too much. So it was hard for the GC to get the right metrics, at least for our use case. But I mean, this was an idea that we started to work on. So basically, working or evolving from this idea, we started to think that maybe pacing the queries could be a good solution for us. And for several reasons. First, because, okay, we are protecting the traffic somehow, okay? We are protecting the OLTP transactions for different reasons. One is because we are reducing the amount of CPU that a single query can take. So if we pace the queries, I mean, at least we can reduce this one core 100% assigned to one just to the wells, but we can reduce that to half a core or even 1/10 of a core or whatever. Okay, but at least to have some control. The other benefit for us is the allocation rate. Okay, we can reduce the allocation rate. So basically, this is a way to help the GC to cope with the memory needs. Okay, and avoid these degenerated pauses. Okay, that are somehow against our interest. Okay. What was our approach? It was maybe a bit simplistic, but basically what we started thinking about was to hint the server which is query and to propose the server an allocation pace. It's not ideal because it's not dynamic, requires some knowledge on your queries about how they are harming the GC, requires some testing, could be hard to maintain and so on, but I mean, it was simpler, let's say, less logic on the server side. We tried several implementation. The one that was selected was coming from an idea suggested by Dan. So thanks, all the credits for you. I mean, was basically based on the fact that you can take the original query and append to the query and an extra syntax that basically allows you to append like a fake condition, injecting a throttle object and calling one of the methods of that object called toThrottle that will always return true to avoid that the result of the select count is different. Okay, and inside this throttle object class and this and with the invocations of the toThrottle, we can do the magic, let's say, okay, to take some timings and from time to time perform periodic smart sleeps, okay, and control the duration of the sleeps, okay. So basically taking as an input the pacing factor provided. Okay, this simple idea works fine and makes the job several benefits. I mean, no need to change the Geode servers. I mean, it was fast and I mean, we were able to implement it. We tried other things. You know that initially we proposed an RFC in order to perform changes on the Geode servers in order to introduce this as a feature. There was a discussion on the RFC. I mean, more or less, this idea was not. We had different proposals, and this idea was, I mean, probably not the best one. Okay, and thanks for all the feedback. We tried also coming from those discussions, the query observer as a mechanism to do this on the server side. But I mean, I think query observer APIs probably need some rework. Okay, it has some limitations and probably, I mean, it could collide with the tracing feature that has the OQLs. I mean, it has some limitations, I would say. Okay, but we implemented it and also worked. Okay, Alberto and myself were doing some job and testing this, and we made it also to work. So maybe I can show you the final result. If it's okay for you, I can make a 1 minute demo. Okay, very fast, nothing very special, but probably you can make a more clear idea. So I hope, is it the font size okay for you to see the screen? I hope it is. I have a Geode cluster, 2 servers. I have a region, all the Dapsus data. Okay, we are using data policy partition, and we have one redundant copy. I will run first the query here. Okay, as commented, basically we're trying to count stuff. So, well, this is a simple one. Entries that are fulfilling this kind of conditions. Okay, if I run this query, okay, you can see that in this case, the query took 6 seconds. I'm not using indexes here because, I mean, just to make it a bit slower and show you some of the benefits. Now I will run with the server function that we are having. We have a function, okay, it's called OQL on primary buckets. I can pass the same query here. And the benefit of this server function is that can better balance the work between all the servers. So we use the optimize right to true. I put this with millets is to indicate the server give me some statistics, and the 0 is I don't want pacing, okay, at this stage. So if I run this, what is the good thing here is more or less half of the time. Why? Because of the more or less the buckets assignment to the different servers. So now both servers are working. Okay, in this case, one server is taking 3 seconds, another case, other 3 seconds. Like signaling basically is a number because this is a select count. I mean, this is nice, half of the time. So one of the benefits. Now, which I will do, if I run this query, and I go to the details, for instance, if I use the top in one of the servers, and I run again the server function, what I will see is that the function, while execution, the CPU is close to 100%. Okay, one core is basically used. Okay, when running the query. But if I use the pacing here, okay, I put a factor of 1. That basically means to the server, okay, I want you to sleep half of the time. Okay, obviously the counters will take more time, but what is the effect? Okay, I'm using half of the CPU, allocation rates reduced to half. Okay, obviously times are double. Okay, you can see here some details of what we are doing. Basically, in these 4 seconds, we have 19 sleeps. The maximum sleeps is 1 second. The final one is 16. The initial is 5 milliseconds. And we are trying to adjust the sleeps to, during 1 second, try to sleep 1000 milliseconds and trying to be processing 1000 milliseconds. Okay, and we are trying to adjust this. So basically, this is how we ended up. Anyhow, probably the interesting part that is just to start the discussion. Okay, so what will be ideal, let's say, is could the server be able to adapt somehow the resources in several areas. Okay, for instance, CPU usage. Imagine that we have many OQLs. Exactly, you have 8 cores with 8 OQLs. Basically, you are speaking all the CPU. Could the server could help to also to I don't know how to call, but to control this beast to allocate resources and ideally prevent that the GC goes degenerated. Okay, I know this is hard to achieve in a Java application, but somehow, I mean, somehow if you don't control this in any manner, then your 30,000 TPS or 10,000 TPS are affected. Okay, by another operation. Maybe an idea is these hints that we are using, like the pacing factor, could be something that could be added. I mean, for instance, in the OQL syntax, to tell the server, okay, this OQL is important for me that you go as fast as you can, or maybe not. Okay, is do whatever you need to do to keep resources under control. And maybe this could go further to OQLs. Maybe this could apply to, I don't know, functions or whatever. Okay, prevalences, whatever. Okay, but are there things that could be throttled or paced? Okay. Maybe going more into the implementation details. I know that Geode has the resource manager that tries to control the resources, but it's more a last resource control. I will say is if you are running out of memory, then I will cut the query, or if you are running out of memory, I will avoid that you to provision more, or in some cases, it's just putting the GC in more aggressive modes. Okay, especially with the CMS has this intelligence, but it's more at this level. But should be evolved to something more, I don't know, advanced, or maybe it's just a dream. I don't know. Okay. Possible tools that could be considered: pacing, concurrency control. How many OQLs can you run in parallel? Max duration of an OQL. If they are too long, okay, cut it. Client hints, quotas. I don't know. This could be the kind of language maybe to consider. And which resources? Okay, CPU, maybe CC. But I think the tricky one is the GC, because it's not about having memory. It's that, okay, GC, you don't have memory, it stops the application and that's it. and maybe the server goes out of the cluster, you know, and this is hard to measure and hard to guess, because probably this is coming, but how do you know it? Okay. Or maybe a different approach could be having building blocks. Okay, maybe it's not an advanced resource manager, but maybe provide some building blocks like an API that you can stop an OQL, because now you launch it, but if it's running, I mean, that's it, it's running and it's harming you, and maybe you can monitor externally and say, hey, stop that query, or stop this, or paste that query, or delay it. Okay, run this query, but when you have resources. I don't know, this kind of APIs. Or some hints as the one that we have done. Maybe what we have done with the server function could be this, for general interest, different balancing to the standard one, like in select counts, that I think that could pay off, or pacing, the one that we are using. Maybe this query observer API could be maybe improved and become public, and then the people can inject their logic there. I don't know. It's a different, probably different way forward, not so advanced, but maybe can be useful, okay, to use cases like us. So, I mean, that's all. It's just, this slide is to try to provoke you and the discussion somehow. And now I promise I will stop talking.
So you have a solution right now that seems to be working, right?
Yes.
Where do you see the biggest delta between what you have right now and the ideal solution?
Well, for us it works. It's true that the ideal solution is cheaper to maintain. Okay, you don't need to do testing in advance. You don't need to characterize the queries. There are queries that we even don't know that they are run. For instance, the system administrator or a troubleshooting engineer is doing a query for troubleshooting, and that was not thought and is not coming via this server function. Okay, and pacing is not applied. So I think there are some kind of deltas, but so far for us, I would say so good. Okay, now at this moment. Okay, it's good enough, our solution for us, let's say. Not sure if you see this kind of needs in other customers or similar problems.
Yes, it seems like something that would be really interesting to a lot of Geode users, I would assume. No one else has any other questions?
Did you think about ZGC as well as Shenandoah when you were doing your GC experiments?
We were thinking also about CGC. We have done some experiments also. We went for Shenandoah because we are now in Java 11. So CGC in Java 11 is experimental. The fixes are not that ported, so I would say it's immature. So Shenandoah is much better in JDK 11. But yes, for us I think they are quite similar, I would say, in terms of what they're trying to achieve. But we focus on Shenandoah because the reasons I commented before. Maybe to comment about this generational Shenandoah, CGC is doing exactly the same job. So I think the same limitations applies because both are not non-generational. So when you stress them with higher allocation rates, then they struggle and they degenerate. And basically they are even worse than G1. Okay, so, but I mean, yes, we are trying and maybe we can, that would be as commented, interesting for another meeting to share our experiences.
And am I right, Evaristo, that your solution it was two parts really. It was one was using the function to distribute execution to the buckets, and then two to do the pacing.
Yes.
You really needed both, and one was something you could do out of the box. The other required an actual change to add the pacing hook into the query language.
Well, like we are using a function instead of adding here the pace. I mean, probably you see my screen. Probably a natural decision could have been to do this. Imagine, but like we are in a function. What we were doing is to pass an argument, but I mean, yes, I mean, probably the hint in the query language itself, and we implemented that actually. Maybe Alberto can comment, but yes, we did that also when trying several stuff.
And aside from what you said earlier about this only really applying to queries that you are able to experiment with ahead of time and find the correct tuning parameter, you're also vulnerable to workload changes over time as your system evolves, and as workloads evolve, these tuning parameters will have to evolve as well. So there's kind of a constant experimentation process that a maintainer has to go through to keep these tuning parameters at the appropriate levels, right? If your system's not static.
No, when, for instance, when you have more entries, I mean, OQLs can go slower. You have more traffic because that day, I don't know, people is, I don't know, the end of the year, okay? Then we have more traffic there, and probably we want to pace more. Several reasons. We have some protection in our system about overload control, that our clients are keeping the horses when needed. Okay, we have that kind of mechanisms. But you are totally right. I mean, this is a constant evolution. Even the queries, the customers, they change. Okay, now they are interested in other kind of queries. Can be more or less complex. So, I mean, it's ideally, if the system could self-tune or self-control, it could be much better.
So an alternative, more ambitious, global approach would be potentially something like a system-wide throttling for queries, for instance, that would entail the query processing interacting with something that allowed it to that allowed the system to throttle all queries, right?
Yes.
You'd have to do something like that if you wanted to protect the system from your system administrators doing ad hoc queries.
Yes. I mean, I see several, as commented, maybe several options. One could be, the most complex one could be to self-monitor the system. I was discussing with Alberto, for instance. You can have the Java flight recorder active all the time in the servers, okay, without dumping, without sending the dumps to the disk. And you can consume the events from the Java flight recorders from an agent or even inside Geode, okay? You could do that and maybe pick the right events and try to figure out, okay, what is my real resource usage in the server? And if I can categorize the stuff, for instance, the OQLs, if I have the hint, okay, this OQL is low priority, I could say, I will not run this OQL now because I reject it, because I know it will harm you. okay, or I will paste this one, and so on, and how much I will paste. I mean, you could do that. That's the more complex. Okay, potentially more complex. But other stuff, for instance, like having in the resource manager a property saying no more than 5 concurrent queries or no more than 2. Okay, so okay, you can have an error as a human, but okay, you cannot put here 20 queries because you make a mistake, because maybe that's a different thing. Or if you run queries that are taking, I don't know, 5 hours, then have you thought about this? Okay, I stop the queries. And even I can catch it and reject it again. I don't know.
That's kind of an endpoint you're describing, pretty sophisticated, and there's certainly a lot of points in between that point and what you demoed today. So one of the things that would be in between those 2 points would be to have the queries interacting with something that could just pause them, right? To say, oh, I'm just going to set things. I'm just going to set that load factor that you're in your demonstration. You set a load factor parameter, right? Yes. That said, I'm going to sleep kind of this ratio. I'm going to sleep this percentage of the time. That could be a global setting as a sort of, in between the grand unified design where we're monitoring events and doing, a closed loop control system. Yes. Something in between what you demoed and that might be a global setting for all queries that let us set this crude load factor, right?
Yes. That would be, I think, a starting point, because if you are, for instance, in our case, OQLs are second-class citizens, okay? Maybe for other applications, that's not the case. But in our case, we are using the map API for the network, okay, the real-time thing. So when we go OQL, we know, okay, we can wait. So a global factor could be good enough for us, actually, probably being conservative. So probably it's simple and I think interesting.
And it could default to no sleeps for out of the box.
Exactly.
Maybe. Yeah.
Exactly. Maybe that will be the simpler of the options, and maybe for some people it's helpful. And maybe it's realistic because the monitoring loop, and I think it's hard, to be honest.
I'm going to use that opportunity there to plug modularity. So there is maybe no default implementation. There's an SPI that you can plug into to provide some sort of resource management or throttling. And if it's not there, it does nothing. And if something's there and registered, it does what's registered. So we're not modifying the core of the code other than to add that SPI layer.
Jake, I'm not familiar with the structure of that query processing, but I imagine that there's some loop in there where we're processing a chunk of data at a time, and so it would entail putting a hook in there, right? That would
Correct.
Delegate out to that SPI.
But at the very minimal, the hook is what you would add to that minimalist change. That hook to go call into something that's pluggable, right? So we're not modifying it beyond that hook.
Neat.
I think query observer for the OQLs is that piece. Probably, right? In which you can plug whatever you want and interact with the queries. But I mean, I think needs to evolve a bit. Actually, we went that way. Actually, at the beginning, and changing a bit the design, making it thread safe, trying to allow concurrent functionalities like the tracing that is currently implemented that way, and our throttling. Okay, I think that's probably an interesting job also to be added as a building block. If you make that API public, you allow the people to plug this kind of functionality, maybe, or whatever. I mean, you can do all the magic you want there, right? But at least this one also.
Yeah, I think, initially keeping it as an internal SPI that we use for, our internal work and our distributions, just to making sure we're not modifying the core. So back to that conversation we had last time for this meeting, is modularity doesn't have to mean it's open and public. It just means you're starting that thought process of, I don't want to mutate the core or mutate the existing behavior. I want to provide an alternative, and providing those pluggable locations to pick the alternative, right? Rather than putting it all in the base code base.
Yes.
And having not even looked at Query Observer, I imagine that if you wanted to use it as is to do what you were doing in the demo, you'd be like blocking the calling thread in some of these Query Observer methods, right? You'd be saying, I'm going to go ahead and sleep when I get this signal under certain circumstances, and I can imagine that being kind of dangerous too, because now you're monopolizing a thread. We might want a different protocol there between the framework and the plugin, right? That allows the plugin to give a signal back to say, time to stop working, and then it allows the framework side to decide what that means, right? And rather than just blocking a thread in an observer.
But the problem is, I think OQLs, all the processing is done in the same thread. So I don't think that you can, well, or I don't know, if you can spam a different thread and try to signal in the observer and trying to, I don't know, signal it to release the task to continue later. I don't know. Probably that requires some refactoring, because the query observer, as if today is I think it's a singleton. I think that's one of the main of their problems, right? So once that you change, you need like to keep it, do your magic, then replace it when you have finished. And so I think requires some refactoring, or the basic thing you can do is to sleep the thread. That's the direct implementation, let's say. Probably not the right one, but at least with the tools available today, I think that's the more direct one.
One more thing we have not investigated is that maybe the OQL query execution can be optimized, because maybe it's not necessary to create so many objects. Maybe we can reuse objects. We haven't looked at the code, but that's something that it's there. So, I mean, that would be targeting this issue here with the lots of objects being created and so on, but we would not be targeting the general issue of resource management. But that's something that can be looked at, of course.
Yeah, having done lots of profiling optimizations in Geode, especially around the put and get operations, I know that there's going to be plenty of places where there's some low-hanging fruit optimizations that can be made in allocations, unnecessary allocations. And if you guys are looking for any kind of help in that process, or how to go about that process, definitely loop me in. Done it a lot.
Sure. Thanks.
Yep. Thank you. Okay, so more or less I understand from your questions that you feel that these building blocks probably at this stage could be the more reasonable to try to progress on this, or what do you think? Or maybe, okay, this is like one use case that we solve this way, and maybe we share and that's it, or maybe I don't know. You think if we progress on this and we can contribute something, or what do you think is the realistic way to make this progress, or maybe not, or maybe it's like it is, and maybe we have already what we have, and you have the servers, you have the functions, and you have the power with the functions, right, to do tons of stuff, and maybe it's not of general interest. What do you think? Do you see this interesting to be evolved somehow, or Or maybe not. Maybe it's a bit too ambitious.
I find it interesting. I think I would take what you have now, if it's working for you, and just make sure that it's modularized so that we're not modifying the core code. And that's a starting point for us to continue to make incremental change on this, right? As you find a new approach or a different approach or even a more optimized approach, you can modify, if it fits within the hooks that you've already added, modify it without and make changes to the core. If it's something we find another place we want to put a hook or a different type of hook, we just start doing that too, and just iterate on this concept of providing those extension points.
Okay, so can we then contribute maybe the query throttler? I don't know, with the function itself. I mean, we did some job in the observer. I don't know, Alberto, what do you think? It was more or less interesting, or I don't know.
Yeah. Well, with the observer, we have an open pull request, which is under discussion right now because, and unless we improve the query observer, right now it's not usable for this task. And what we can try is to provide an SPI, as Jake suggested, and then offer this implementation as one implementation. I mean, if there's an implementation, nothing happens in the OQLs, but you can have this implementation of ours as an example, and then, I mean, work on that further.
I think you've made a great point in highlighting a lot of ways we could improve the general areas that I would be very surprised if those wouldn't be valuable to other users as well. So if we can iterate towards that in a modular fashion, as Jake suggested, I think that would be fabulous.
Okay. Then, I mean, that's good. Thanks. And I mean, we can try to at least provide what we did, I think.
All right, coming up on time. Any other questions from anyone? Well, if not, thank you so much, Evaristo, for the presentation. I thought this was incredibly interesting, and thanks for all the amazing contributions to the community.
No, thanks to you. Okay, nice to be here.